you guys already know from exponents. So, for example, x squared times x to the third. As long as you have the same base, which is x, what do I do with those exponents? Yeah, you add them, right? Okay? Add. You might want to make a little note of that, right? So x squared times x cubed is x to the fifth. So if you have the same base, you add exponents. And then the other rule that we've learned is when you have a power to a power, then what do? That's when you multiply and you get x to the 6. Alright? So when you're multiplying, you add, but when you have a power to a power, you multiply. So let's try one of these problems where we have variables in our exponents. So I have x to the m times a to the 3x times x to the m over 5 times a to the x over 2. So the ones that get to add, because there's no parentheses and no powers, so there's no multiplication in this problem, we're just adding. And we're adding the stuff that is alike. Alright, so let's add exponents, and off to the side maybe somewhere, or wherever you want to add exponents, we're going to end up with an x, and then we just have to add m plus m over 5. We need a common denominator of 5, so I would multiply this one by 5 over 5. So then what I really have is 5m plus 1m, and so we get 6m over 5. Okay, and then for the y's, or the a's, say we're going to add this, we're going to add this, and we're going to combine it so we have one base. We're going to add those two exponents. So off to the side somewhere maybe, I have 3x plus x over 2. So what do I have to multiply this first one by? Yeah, we have to multiply it by 2 over 2 here to get a common denominator. So then I have a 6x plus a 1x gives us a 7x over our common denominator. So it's the same rule, they're just making it a little harder by giving you variables in your exponents. Let's try that one. So I'm going to write that down. M to the a minus 2, p to the a plus 1, all over m to the a over 3, p to the 2. Alright, so if you have something in the denominator, all we need to do is move it to the top and change signs, right? So it either becomes, if it's negative, it becomes positive, if it's positive, it becomes negative, right? So I'm going to put it all in the numerator first. So my first step is rewrite what I have in the top here. So I'm keeping the top the same. And then I'm going to move this to the top. And what happens to the exponent? Becomes negative a over 3. And then I'm going to move this p to the top, and what happens to the exponent? Becomes negative 2a. Show work on these, alright? As much work as you can. Now we add the exponents that are friends, so the m's, right? So I'm going to add a minus 2 and negative a over 3. So maybe off to the side somewhere I have a minus 2 minus a over 3. So that's everything that's in the exponent, and it's all adding, but only some of that actually adds together, right? Which stuff actually gets to add together? The a's. Only the a's, right? You can't add a number with a variable. So just the a's. So I need a common denominator. What am I going to multiply this first one by? So I can add it with this one?
3.
Yeah, 3 over 3. So now I can add them together. So now it's combining into 1. So m is still my base, and I'm adding exponents. So 3a minus 1a over 3 is 2a over 3. And then this minus 2 just stays minus 2 in the exponent. And That's all the stuff that's in the exponent of the p's. So what's 1a minus 2a? Negative 1a plus 1, or just negative a plus 1. So we add exponents, but we only add stuff that is alike. And now we have our simplified version. All right, now we've got powers. So it's a little different. So I've got a power now instead of just adding or subtracting. So what do powers do when we have a power to a power here? Yeah, the rule is to multiply. And the 2 is going to multiply to everything here. It's going to distribute to that top part. So I get 2a plus 4. That's my answer. Okay, so I multiplied it by distributing. There's a plus sign in there, distribute it. All right, let's try another one that has multiple things going on. So it's combining everything that we just did. So x to the a to the b, y to the a to the b plus 2 over x to the negative a. All right, if there's parentheses, what do we do with these here? Multiply. And what do we do with these? Multiply. And this is another one where it's going to distribute, and you have that plus sign in there. And this one right here is just going to move to the top. And when it moves to the top, we change the sign of the exponent, right? So in the numerator here, we're going to have x to the a b. They multiply together. And then in the numerator here, we're going to have y to the, what is this going to give me? Yep, ab plus 2a. And then this moves up. And when we move it up, what happens to this negative a? Positive a. Okay? Now, which ones are friends, and can we add together? Not true. The ones that have a base of x. So if they have the same base, which is x, what do I do with these exponents? We add them. Okay, are those like terms? No, so they don't really add, but we can write them as 1, which is ab plus a. And then I have my y. And my y stays the same, so ab plus